Now we have fundamental theorem of arithmetics. So what is it? Fundamental is nothing but basic. Theorem means the statement we have to prove it. Arithmetic, it deals with addition, subtraction, multiplication and division. So simple, okay, it is the arithmetic is the branch of mathematics, right? So here this theorem we have to prove it. What is the statement for it? As we know, what is the Euclid's division lemma? A is equals to BQ plus R. Here if we put remainder 0, what will be the thing? A equals to BQ. So what is the relation between A is equal to BQ? Here the relation is nothing but A is the product of B and Q. A is product of B and Q. Q is quotient, B is divisor. Okay, divisor and quotient. That is A is nothing but dividend. Dividend is the divisor into quotient. Q is nothing but quotient. So this is the relation. So here what we are going to do, before we start this, let us know about the HCF and LCM. What is HCF? HCF is, the full form is highest common factor. Everyone knows the full form, but what actually we are doing in HCF? Suppose we have two numbers 6 and 12. You have to find the factors of 6 and 12. What are the factors of 6 and 12? 6 has 1 as a factor. 1 is a factor of every number 1. 2 is also a factor of 6 because 2 3 is a 6. 3 is also a factor of 6. 3 2 is a 6 and 6 1 is a 6. Obviously 6 is a factor. Now what about 12? What are the factors of 12? 1, 2, 3, 4, 2 6 are 12, 3 4 are 12 and 6 and 12. So these are the factors of 12 and these are the factors of 6. You have to find HCF of these two numbers, highest common factors. What all these numbers are? These are the factors of 6 and these all are the factors of 12. What you have to do is highest common factors. 1 is common in this 2, 2 is common here, 3 is common factors and 6 is common. So what is the highest common here? 6. 6 is the highest common factor. So HCF of 6 and 12 is 6. So this you can take, HCF is 6, highest common factors. 1 is also a common factor, 2 is also a common factor, 3 is also a common factor, but among these 4, 6 is also a factor. Among these 4, which is the highest one? 6 is the highest one. So HCF of 6 and 12 is nothing but 6. If you want, we can check by division method. That is smaller we will take as a divisor. 6 to the 12. Remainder 0. See, as we are in the previous class, I told you that if we are getting remainder 0, the divisor will be the HCF. So see, in the division method also we are getting 6 as the divisor. That is HCF. So that is highest common factor. I think you have understood now about the HCF. Now what I am saying here is to explain the statement of the fundamental theorem of arithmetics. So I think you have understood about the factors. After this you should know about the prime numbers. Before we start this, you should know about the prime numbers and composite numbers. What is this? What these are? Prime numbers means the numbers which has only two factors, 1 and itself. You can note down this. The numbers which has only two factors, that is 1 and itself. Right. I will give you some examples. Wait. Now composite numbers, the numbers which has more than two factors. The numbers which has more than two factors. Right. So can you give some examples? I think I have to give the examples. That is the examples of prime numbers. That is 2. 3, 5, 7, 11, 13, like this. Why these numbers? Because this 2 has only two factors, 1 and 2. It has only two factors. 3 has only two factors, 1 and 3. 5 has only two factors, 1 and 5. That is 1 and itself. 7 has only two factors, 1 and 7. Like this, 11 and 13 also. 11 has only two factors, 1 and 11. 13 has only two factors, 1 and 13. Like this, similarly we have some prime numbers and so on. Composite numbers means the number which has more than two factors. For example, it starts from the 4. 4 has two factors, 1, 2 and 4. It has three factors. What about 6? 4, 6. 6 has 1, 2, 3, 6. Right. Similarly, 4, 6, 5 is not there, 6, 7, 8, 9, 10, 12, 14 and so on. These are the composite numbers because they are having more than two factors. Look, 4 is having more than two factors, 1, 2 and 4. 6 is also having more than two factors, more than 2, right? It has 4 factors. 9, sometimes by mistake students use the 9 as a prime factor, but it is not a prime factor. It is a composite because the factors of 9 are 1, 3 and 9. 3 is also a factor of 9 because 3 3s are 9. So 9 has 3 factors, so 9 is a composite number. Hope you have understood about the prime numbers and composite numbers. Why I am explaining this prime and composite? Because in this theorem we are going to understand there is a relation between prime and composite in this theorem. So let us know about this statement. What is the statement of this theorem? So I am writing here the statement of this. Every composite number, okay, every composite numbers can be expressed as product of primes. So here composite numbers can be expressed as product of primes and this factorization is unique. And this factorization is unique. Apart from the order in which, so this is the statement, every composite numbers can be expressed as product of primes. Composite numbers you have to express as product of primes and this factorization is unique. Apart from the order in which these primes occurs. Like this, as I told about the 9 I am writing as 3 into 3. 9 is a composite number, so this we are writing as product of primes. That's why I am using this Euclid's distribution lemma A is equal to BQ plus R, in which if you are taking remainder 0, it is nothing but A is equal to BQ. So this is nothing but A is the composite number. Composite number is the product of primes. So these two are prime. So that is the statement of the fundamental theorem of arithmetic. Composite numbers is expressed as product of primes. What about 12? 12 we can write like this. 2 6 are 12, 2 3s are 6 and 3 1s are 3. This we can write as 2 into 3. So because 2 is repeating here, we can write as a exponential form 2 square into 3. In this way we are writing. So here 12 is a composite number. This we are writing as a product of primes. Right. Now what is the general form of this general form we have to write about this. Now we will write the general form here. So what is this? We have to write it as composite numbers. Composite numbers is nothing equals to product of primes. That is only the theorem. That only we have to do this. Composite numbers is nothing but expressing composite number as the product of primes. That means suppose if we are taking x, this is the general form I am writing. Okay, general form. That is, suppose we are taking composite number as x. It can be any composite number, not only 9, 6 and whatever examples I have taken. It is not like that. Composite numbers, any composite numbers it can be. So we are writing it as x. X is equal to product of primes, p1 into p2 into p3 into so on up to pn. So we can get infinite prime numbers based on the composite number. If it is a 4-digit number, if it is a 5-digit number, the answer will be quite bigger. That is, the product of primes will be more. p1, p2, p1 into p2 into p3 into pn. What are all these numbers? These are nothing but primes. X we are taking as a composite, p1, p2, p3, these are nothing but primes that we are multiplying, product. So p1 into p2 into p3 and so on. And these primes you have to express as, whenever you are writing, p1 should be less than p2, p3, like this you have to write. Okay, p1, first prime, the smaller you should write here. So this is the general form of the fundamental theorem of arithmetics. And suppose if the primes are repeated there, suppose I have given the example of 12, right? 12, 2 6 are 12, 2 3 are 6, 3 1 are 3. I have given this example previously. So this how we are writing. Since 2 is repeating coming 2 times, this prime we are writing as in the exponential form, 2 square into 3. So same number like this. So instead of writing 2 into 2 times, we are writing 2 square exponent form. In this way we can also write the composite number. Okay, so this is the fundamental theorem of arithmetics. Now we will do some problems. Express the following as product of primes. Now we will do some problems. The first one is 2310. This is a composite number. This you have to solve and write as a product of primes. How to do this? 2310. This you have to factorize. First you have to factorize. The last digit is 0. We can divide this by 5. So 2 will not come here. So we will take 2 digits. 5 4s are 20. So what is left here? 3, 31. Then 5 6s are 30. Then we will have 1. 5 2s are 10. Understood? 5 4s are 20. 3 is left here. Remainder, that is we are writing here 31. 5 6 are 30. So 1 again 1 is the remainder 10. 5 2s are 10. Now 2 is there. We will divide by 2. 2 2s are 4. 2 3s are 6 and 2 1s are 2. Then what about this 231? You have to check by which number we can divide this. We don't want any remainder over here. Exact, it should be divisible. So since it is the last digit is 1, it is not divisible by 2. So we are not taking 2 here. So what we can do, 5 also we can't take. Let us check. We have to check it first. 7. I am just checking it. 7. 7 3s are 21. Okay, 21 we are getting. So what is left here? 21. Again 7 3s are 21. So we can divide it by 7. 7 3s are 21. 23 is there. 2 is left here. Again we got 21. 7 3s are 21. Now what about 33? It can be by 3. 3 1s are 3. 3 1s are 3. 3 11s are 33. Now 11 1s are 11. So these are the product of primes. 5 into 2 into 7 into 3 into 11. All these are the prime numbers. Now here, so this 2310 we can write as, okay, 5 into 2 into 7 into 3 into 11, right? But as I told you, the smaller you should write first. Okay, so we can write 2 first. 2 into 3 into 5 into 7 into 11. So that is the answer for it. 2310 is a composite numbers we are writing as product of primes. No number is repeating here, so simple 2 into 3 into 5 into 7 into 11. So this is the answer. So this is the first one we have done. Now let us do another one. Now next one is 5005. Let us factorize this. Factorization you have to do to write it as the product of primes. There, or else we can write here also. We can factorize here 5005. Right. How to do this? Since last digit is 5, we can divide it by 5, because rules you should know. While dividing this, what is the rule of 5? If the last digit is 0 or 5 of any number, we can divide this by 5. If the last digit is 0, 2, 4, 6, 8. If these are the last digits, we can divide by 2. This is the simple rule for 2 and 5. But for others also there are the rules. But these are the simple rules we can easily follow here. 5 on the 5, 5 zeros are 0, 5 zeros are 0, 5 on the 5. What about 1001? What are the factors can be of this 1001? You have to try this. You can check over here. Let us check. Let us check by 7. 7 ones are 7. Answer we are getting 7 here. 10 minus 7 is 3. 7 4s are 28. We are getting 30 here. So 7 4s are 28. 29, 30. 2 is left. 2 you should write here. 7 3s are 21. Right. So we are getting, we can divide this by 7. Because 1 is there, we can't divide by 2. Now let us do this. 7. 1 will be not there. We are using 2 digits. 7 ones are 7. So this is 10. 10 minus 7, 3. So 3 remainder we are writing here 30. 7 4s are 28. 7 5s are 35. 35 we can't use. So 7 4s are 28. 7 4s are 28. So the left one is 2 here. 7 3s are 21. Now again after this 143. It can be, yes, we can divide this by 11. 11 ones are 11. 14 is there. So 14 minus 11, 3. 11 3s are 33. 13 answer. So 13 ones are 13. Till we get 1, you have to factorize. This is called factorization, to writing the composite number as product of primes. So 5005 is a composite number. So this we are expressing as 5005 is nothing. We are writing as 5 into 7 into 11 into 13. So this we are writing as product of primes. So this is the answer, right? Now next problem, 7429. Okay, this is also a composite number. We have to factorize this. Let us see. Here, let us see this one, 7429. Before we start here, we will check it in the rough column. 9 is there. Let us, it will not divisible by 2. So let us check by 3. 3 to the 6. 3 4 the 12. 3 7 the 21. 19 is left. Nothing. So we can't take 3 here. So let us check by 17. I have gone through this. It is here we have to take the 2 digits prime numbers. So 2, 3, 5, 7, 11. These prime numbers are not suitable in this problem. So I have seen this. That is 17 is we have to divide this by 17. 17. Okay. Let us check. 29, 17. Okay. Let us see. Let us check by 4 because it is 74. 4 7s are 28. 4 1 are 4, 5 6, 68. Here it is getting 68. So we can take 17 4s are 68. We are getting 68. But the question is 74. So you have to subtract 74 minus 68. 68, 69, 70, 71, 72, 73, 74, 6. 6 is there. We are getting 62. 17 4s are 68. Right. We want 62. So we will multiply by 3. 3 7s are 21. 3 1 are 3. 3 7 3 1 are 3 4 5 51. So we can take 17 3s are 51 here. So we are taking 17 3s are 51. But you have to subtract, no? 62 minus 51. 2 minus 1 is 1. 11. The remainder we are getting is 11. 119. We want 119. By which number we should multiply to get 119? 17 4s are, we will take 17 6. 6 7s are 42. No, it is not coming. We want 119. Okay, 119 we want. Last digit is 9. So 7 7s are 49. 7 1s are 7. 8 9 10 11. 119. So we are getting 17 7s are 119. We are not getting a remainder 0. We are getting remainder 0 here. So we can apply 17 here. 17 into 437 is this answer, 7429. So prime number is nothing but 17 here. Now what about this 437? Here this we can't divide by 2, this we can't divide by 3, 5, 7. We can't divide by the simple numbers. So 17 is there, we have to do it by another number, that is 19. You have to check it. 17 is there, 17 is also a prime number. So this is a big, because 4-digit number and it is a multiple of 17 into 19 and one more prime number is there. We will do it. Okay, we are doing now 19, 43. 19 ones are 19, 19 twos are you have to take. 2 9s are 18, 2 1s are 2, plus 1 3 38. Yes, we can apply this. 19 twos are, okay, 19 twos are 38. Answer is 38. So you have to subtract 38, 39, 40, 41, 42, 43. 5 is left out. 57. So 19 threes are, we want 57. So 19 threes are how much? 3 9s are 27, 3 1s are 3, 4 5 57. So 19 threes are 57. We got 23. 23, as we all know, 23 is a prime number because it has only 2 factors, 1 and itself. So 23 simply we can write as 23 ones are 23. So we got the we got here 1 here. So these are the numbers, primes. 7429 we are writing as, we can write as 17 into 19 into 23. Hope you have understand the fundamental theorem of arithmetic, that is composite number is equals to product of prime numbers. So that the theorem problem, based on that theorem we have done these problems. Okay, hope you have understood.